Properties of a conductor. First property of a conductor is that inside a conductor electric field is always zero, because in this case charges are in movable condition, so electric field inside the conductor is zero. Next property is, suppose we have a conductor of any shape and we give charge to it in the interior of this charge, so that charge does not stay inside, it appears on the outer surface. So inside a conductor excess charge cannot stay, it comes out. That means कोई भी extra charge आप इस surface को देंगे तो वो इसके interior में कहीं पे नहीं रुकेगा, that will come or appear on the surface of conductor. Third property is, if we have a conducting surface and it has charge, then the electric field at any point on this surface will always be perpendicular to this surface. वो इस direction में ऐसे या और along the surface नहीं हो सकती है. Reason is, suppose we assume that the direction of electric field is this. If this happens to be the direction of electric field, it will have two components. We can show here. Suppose direction is this side. It will have two components, एक perpendicular, that is say E1, and another along the direction, that is ET. So in this case, electric field will have a component along the tangent of the surface, and in this case, the surface will have some electric field, whereas in conductor we say that there is no electric field inside the conductor. Next property is that inside the conductor potential from surface to the center is constant. Center से लेके surface तक at every position potential is constant. Then next property is when a conductor is placed in external electric field. Suppose एक electric field already इस area में present है and a conductor is placed here, then surface charge density at the surface of this body will be different at different places. Sigma will not be same, it will be different at different places. Capacitance of a conductor is the property of conductor to store charge on it. Suppose this is a surface, conducting surface, and we are supplying charge to this Q charge, then it has certain capacity to store the charge on it, which is called capacitance. The charge given to this surface, that is directly proportional to electric potential, because as we keep giving charge to this, its potential will increase. V is K into Q upon R. So if we increase Q, potential of the surface will increase. Remove this proportionality sign, we get a constant C here. This C is called capacitance of conductor. From this formula, C is Q upon V, that is coulomb, unit of charge is coulomb, V is volt, so this is 1 coulomb per volt, which is called farad. This is the unit of capacitance, farad. One farad is a very big unit. We can understand it from the statement that the capacity of Earth is only 711 microfarad, and whereas Earth is very big in size, but its capacity is so small, so farad is a too big unit of capacitance. Capacitance of a spherical conductor. How do we measure this? We have a spherical conductor, suppose, and Q charge is supplied to it. This radius is R. Then potential on the surface of this conductor will be equal to 1 upon 4 pi epsilon naught Q upon R. Now from this formula, take this V to right side, Q upon V, and that is equal to 4 pi epsilon naught R. Q upon V is capacitance of the conductor. So for a spherical conductor, C depends upon its radius. So that means a smaller spherical surface will store less charge, and if you increase its radius, its capacity or capacitance will increase because it depends upon R. When we have a conductor and we supply some charge to it, then its potential increases. Now there is a limit of this surface to have a maximum value of voltage on it. So हम एक लिमिट तक इसको चार्ज सप्लाई कर सकते हैं. When conductor is in its saturation position, that it has taken maximum charge, after that it will not take more charge. So to increase its capacity, we use another method, and we design a device called capacitor. Capacitor is a device that is used to store large amount of charge in small space. बहुत छोटी सी जगह पे हम बहुत ज़्यादा amount of charge को store करके रख सकते हैं in the form of capacitor. I would like to show you what is capacitor. Capacitor is of this shape, cylindrical shape, and it has two legs. One is the bigger leg and the other one is smaller leg. This device is called capacitor. I can see that the capacitance of this capacitor is, if it is visible, it's 220 microfarad. This is 220 microfarad. Another capacitor, small capacitor, it's smaller in size, but its capacity is more. This is of 470. The capacitance of this capacitor is 470. This type of capacitors are used in fans. This is bigger in size, and this is used in fans. Now, how does the capacitor work? You see, principle of capacitor. Principle of capacitor is, suppose we have a conducting rod and it is placed on an insulating pad. This is insulating pad. and we supply some charge to this rod so that it reaches to its maximum potential. After that, when you supply more charge, this rod will not take. So this is a single conductor. It has stored charge up to its maximum capacity. But अब हम इसकी capacity को और increase करना चाहते हैं. तो उसके लिए what we'll do? Place another conducting rod in front of it, uncharged, and on insulating pad, we place one rod in front of this. When we place conducting rod, this rod, say this is A, this is B, this rod will induce negative charge towards this side, and all positive charge will go on the back side of this plate because of the induction. This positive charge will induce all the negative charge or attract negative charge towards it, and will repel all the positive charge away from it. Now, because in the vicinity of this positive charge, there is negative charge, there is another positive charge. So, total potential of this rod will become, if I say VA, this will be this charge plus Q, this charge minus Q, and another this charge plus Q. This charge has the least distance from this rod. This has slightly more, and this is at the maximum distance. So, as negative charge is closer to rod A, so its effect on the potential of the rod will be maximum, and its potential will reduce. The net potential of the rod will reduce. Because if I see, इस चार्ज का तो पोटेंशियल पे कोई रोल होगा नहीं, एंड नेगेटिव चार्ज इज नियरर, तो ये वैल्यू ज्यादा है, पॉजिटिव चार्ज दूर है तो ये वैल्यू कम है. सो इफ आई सी दीज टू, देन दिस विल बी मोर, दिस विल बी लेस, सो नेट पोटेंशियल will decrease. Now, if the potential of A decreases, then to take it to its maximum value of potential, we can supply more charge to it, and it will take now more charge. Its capacity will increase. Now, we further want to increase its capacity. एक amount of charge और supply हो गया, but after that also we want to increase its capacity. We'll connect it to the earth. When we connect it to the earth, negative charge is bound to this positive charge. It will not move, but all this positive charge will move to the earth, and then we'll have rods. This is connected to earth. So this will have only positive charge. This will have only negative charge. So now this charge which was contributing to potential of A is no more over there, and only negative charge is present, so it will further reduce the potential of plate A. And now to increase its potential up to the previous value, we can supply more charge. So basically we can say that the capacity of a conductor or a conducting surface can be increased by placing another conductor which is uncharged and near to the previous conductor, and then connecting it to the earth. This device, this combination is called capacitor. Parallel plate capacitor. Generally जितने भी capacitors होते हैं वो सभी parallel plate capacitor ही होते हैं. If we are taking parallel plate capacitor, suppose ये एक प्लेट है, ये एक प्लेट है. पेपर पे ड्रॉ करने के लिए सिंबल कैपेसिटर का ऐसे दो पैरेलल प्लेट्स जैसा बनाया जाता है, बट ये एक्चुअली आपकी सरफेसेस होती हैं इस तरह से. ये सरफेसेस हमारी सिलेंड्रिकल भी हो सकती हैं, स्फेरिकल भी हो सकती हैं, एंड दोनों प्लेट्स पे, एक प्लेट पे जितना पॉजिटिव चार्ज होता है, दूसरी प्लेट पे सेम अमाउंट ऑफ नेगेटिव चार्ज होता है, एंड द सेकेंड प्लेट इज अर्थड. Suppose area of a plate is A, surface charge density of first plate is plus sigma, and surface charge density of the second plate is minus sigma. Distance between these two plates is d. Now we have to derive an expression for capacitance of capacitor. कैपेसिटेंस के लिए हम इसको स्टार्ट करते हैं इलेक्ट्रिक फील्ड बिटवीन दीज टू प्लेट्स. यहाँ पे पॉजिटिव चार्ज है, यहाँ नेगेटिव चार्ज है, सो ऑब्वियसली पॉजिटिव चार्ज से नेगेटिव चार्ज की तरफ इलेक्ट्रिक फील्ड लाइंस डायरेक्टेड होंगी ऐसे, तो इन दोनों के बीच में एक इलेक्ट्रिक फील्ड प्रेजेंट होती है. इफ आई टेक इलेक्ट्रिक फील्ड ड्यू टू सिंगल शीट, वी नो दिस इज इक्वल टू सिग्मा अपॉन 2 एप्सिलॉन नॉट, अगर इन दोनों प्लेट्स के बीच में एयर है या फ्री स्पेस है. एंड सिमिलरली दूसरी प्लेट की जो फील्ड होगी वो भी आपकी सिग्मा अपॉन 2 एप्सिलॉन नॉट होती है. एंड एक पॉजिटिव प्लेट है, एक नेगेटिव प्लेट है, बीच के किसी भी पोजीशन पे इसकी इलेक्ट्रिक फील्ड विल बी अवे फ्रॉम इट एंड नेगेटिव प्लेट की वजह से टुवर्ड्स, सो बोथ विल एड अप. टोटल इलेक्ट्रिक फील्ड बिटवीन द प्लेट्स विल बी sigma upon epsilon naught. Now here sigma is surface charge density. This is surface charge density and its value is Q upon area of the plate. Q is the charge which is present on one plate. So E will be equal to Q upon area into epsilon naught. This electric field can be written in terms of potential. E is equal to V upon D. This relation comes from the equipotential surface. So this is Q upon A epsilon naught. Q upon V, V नीचे आएगा and this will be epsilon naught A upon D. This Q upon V is capacitance of capacitor, which is equal to epsilon naught A upon D. This formula shows that capacitance of a capacitor depends upon first factor area of the plates, second factor distance between the plates, and third factor epsilon naught, because formula में है, that means medium between the plates. That means इन दोनों प्लेट्स के बीच में इस जगह पे जो मीडियम होता है कैपेसिटर की कैपेसिटेंस उस पर भी डिपेंड करती है. इफ दिस स्पेस इज फिल्ड विद सम अदर मीडियम, सपोज फिल्ड विद मीडियम जिसकी परमिटिविटी सपोज एप्सिलॉन है, इफ दिस परमिटिविटी इज एप्सिलॉन, सो उस केस में कैपेसिटेंस Cm विल बी एप्सिलॉन A अपॉन D. एप्सिलॉन को हम लिख सकते हैं एप्सिलॉन नॉट इंटू K इंटू A अपॉन D. सो दिस बिकम्स K C नॉट. दैट मीन्स मीडियम डालने से दोनों प्लेट्स के बीच में अगर कोई मीडियम इंसर्ट होता है तो हमारी कैपेसिटेंस इंक्रीज हो जाती है. Whenever you put a medium between the plates, the capacitance will increase. If K is infinity K मेटल सर्फेसेस के लिए होता है, तो उस केस में हमारी Cm जो है वो इनफाइनाइट हो जाएगी. Then its capacity will become infinite.